Hi, my name is Michael Rabalais, and today I'm here to talk about geothermal power plants. So what is geothermal power? It is a clean and sustainable form of energy that is produced from heat supplied by the earth. It can range from just using latent heat that's being absorbed just under the Earth's crust, all the way down to taking heat from well down below like the bedrock, several miles under the Earth's crust, from like the superheated liquid and like the magma that's below the Earth. So where around the world, specifically in the United States, is this common? If you look at a world map, you can see kind of the areas where you see a lot of earthquakes along our west coast, as well as like Japan and Korea. This is because it's like the deep forms of energy around like where the tectonic plates are moving past each other. Over on this side, in the United States, it's a little bit further up close view. A university did a study of where the optimal locations were in the United States to like put a geothermal electrical power plant, and all along the west coast, like the Sierra Nevadas and Rocky Mountains, but kind of the northwest corner of Louisiana as well, around Shreveport. They said it'd be a favorable area if they wanted to build an electric power plant from geothermal power. So in the industrial sense, it's used for power generation, for commercial, large buildings, especially in like downtown cities, can be heated and cooled using it. Same thing with your residential home. That'd be more of like a heat pump, similar to what we did in like the refrigeration lab. So I have a couple videos, kind of skim through them real quick. The first one is going to be on a residential.
Geothermal energy options, how it works.
Geothermal heating.
I'll just kind of talk you guys through it. So basically what they do is they'll drill holes into the ground. Can you see it?
Yep.
Anyway, they drill holes in the ground and they run loops of pipe through it. Typically it's for your refrigerant that's going to be flowing through the system. And then just kind of like internally, what you'll have is very similar to the refrigeration cycle that we had, except your condenser, rather than being like a heat exchanger, it's pipes that are running into the ground. But it can be reversed. So if you want to create heat, you can compress the air, or compress the gaseous refrigerant that the earth is supplying heat to, compress it, and then a fan blows across it once it gets into your house to heat your home through the expansion valve, and it condenses it again. But in the summertime, the cycle can be reversed, and you'll be blowing a fan across the cold refrigerant and cool your home. For an industrial setting,
Welcome to one of Cal Energy's geothermal.
they drill down deep into the earth. Several miles, usually between 5,000 and 10,000 feet, to where they have reservoirs of water that are down below the bedrock that the core of the earth is actually heating, and it's a superheated liquid. And then from there, as it returns to the surface, it starts to expand because of the loss of pressure, and it goes through just basically ranking cycle. They lower the pressure, capture the steam, bring it through turbines, and use generators to create electricity. So in the industrial sense, when creating electricity, comparing it to nuclear, gas turbines, and coal, it's the energy supply when compared to nuclear can be kind of limited because you can really only have it in certain areas of the United States. Also, its efficiency is much lower because you have a lot of losses when you're bringing the superheated liquid up to the surface. So if you're using it as a heat pump in your home, it actually has a better coefficient of performance than the refrigeration cycle we studied, usually between 3 to 5. But the power plants have efficiencies between 10 and 17%. It kind of depends on how many stages of, like how many high, low, or medium pressure steam you can capture. Some of the advantages, relatively environmentally friendly if it's managed properly. The reservoirs are naturally replenished from rainwater. However, you go through droughts, you can have issues with that. And they claim that there's up to 2 terawatts of potential within the earth. Some of the disadvantages, like we said, it's location specific. It has higher upfront costs, and they claim that you can have it can cause earthquakes. So I think that it can shape the future by the potential of, again, a residential setting. You have slightly higher upfront costs, but they claim that you can save between $80 and $100 a month on your heating bill, and it's only about an extra $2,000 to get it set up in your house when compared to a typical air conditioner. And it's another form of renewable energy for our planet. It helps us break the dependence on non-renewable energy. So, any questions?